Hello. So right now we are going to start factoring special cases, difference of squares. So now when we look at difference of squares, then what that means is we need to have difference, so there needs to be a minus sign, and we also have to have two perfect squares. So it'll look like this. It's going to look like x squared difference, so we will have a minus sign, and then maybe we'll go with, I don't know, 25. So there will be two perfect squares here and here, and this is what we are going to want to factor. Now remember, a square or a perfect square, that's one of those numbers that you find when you multiply a number times itself, like 25. 25 is equal to 5 times 5. So we have two of the same factors that will give you 25, and that's what makes it a perfect square. So remember, right here, the whole thing is that we have two of the same factors. So for a difference of squares, that means we're going to have the same factors here. Well, if this were a trinomial, then we would have set up two sets of parentheses, we would have put an x in the beginning of each, and then it ends with a minus 25, so we would have said something like, well, we have to multiply to get 25, and subtract to get, well, I don't know, there is no middle term, but we have to multiply to get a negative 25 anyway, right? So let's do a plus and a minus. And one of the ways that we can multiply to get 25 is 5 and 5. So let's use that guess and check method. Let's say that we have this right here. So now what we are going to do is we are going to distribute. So we're going to go x squared minus 5x plus 5x, and then positive times a negative is negative 25. And look at these guys here, they cancel out. So this is the same factors, and that's why when you factor this, this is going to go here and here. Okay, so now let's move on to down here. Oh, you know what? Let's kind of give you a basic kind of a definition. So now a squared minus b squared. Okay, so it's the difference. You must have a minus sign. Must have a minus. Of squares, two terms. So that's what's going to make this guy different than the other ones that you've done, because we have only lately been doing ones with three terms, doing the trinomials. All of these polynomials are binomials. They all have two terms. Okay, so two terms is a hint that we might use difference of squares, and a minus. The other thing is that your first and last, or both terms, have to be perfect squares. And when they are, square root of the first, square root of the back, b and b, and one of each sign, a plus and a minus. And we do want one of each sign because, as we see, if we were to FOIL it out, then those two terms in the middle would cancel out. Oh, look at that. We just did this one. So parentheses, parentheses, x in the beginning of each, plus 5 and minus 5. This guy right here, two sets of parentheses. Y in the beginning of each, one of each sign, plus and minus, and 100. Well, if I take the square root of 100, that's going to be 10 and 10. Remember to always take the square root of this number and split it evenly, because when you do multiply it out, you are multiplying these two numbers to get the 100. Common mistake is that people will write 50 in a situation like that. Okay, so two sets of parentheses in the front. Okay, so sometimes there are two different parts. So we're going to split the 4 square root, that's 2 and 2, and split the a evenly. Well, 1 is 1 times 1, right? Because that will bring you back to 1, and a plus and a minus. Okay, so this guy over here is looking pretty good. Two sets of parentheses. Square root of the number, 4 and 4. And for our variables, we just split the powers evenly. A squared, a squared. So if you are to multiply here, you will get the 16a to the 4th. In the back, we're going to have square root, so that's 5 and 5. b split evenly, b and b. One's plus and one's minus. So it's the same exact term. One has a plus, one has a minus. Now we move on to number 5. So number 5, we have two terms, check. We have a minus sign, check, but we don't have two perfect squares. What's a 20? You can't nicely take the square root of 20 and have it be equal to an integer. So this one right here cannot be factored anymore, so we are going to say that this is prime. The only other way you would be able to factor something with two terms is if it had something common. Maybe this was a 2y squared, and then you could factor out a 2, but we don't have that. Number 6 over here, let's check this one out. So here we have x squared plus 9, okay? Two terms, check. Square and square. The problem here is that we have a plus sign, not a minus sign. So this one we can't factor. So I know what you're thinking. You're thinking, well, why not just go with x plus 3 and x plus 3? Because the pluses. Well, if we were to do one like this, then we would get x squared plus 3x plus 3x plus 9. And if we combine terms in the middle, it's going to give us a 6x. And these are not the same because this here, we do have that 6. We don't have it here. This guy cannot be factored. So that's not going to work. He's prime. Okay? So again, when we do this, we have to remember minus sign, two terms, and they have to be squares. Let's put that there too. Okay, so those are the things that we need to look for. And we did not have that in 5 and 6. Number 7 is a goodie. Okay, so for this one right here, two sets of parentheses. I'm going to make them big because there's a lot happening. This number, square root, 7. Variables always split evenly. So I see that these are all even variables. So I am able to split them evenly. I'm going to go ahead and do that. So there's my x squared y to the 4th, x squared y to the 4th. A plus and a minus in the back for my second term. Square root of this, it's going to be 8 and 8. Split your a's evenly and the b's. B to the 5th, b to the 5th. And that guy is done. Here's my last one. I like this one. So for this, we have a minus, two terms, something squared. Okay, so it's a variable to an even power. And that means that we can split it evenly. And that's a perfect square. So two sets of parentheses. And then I have my x squared and x squared, a plus and a minus, 9 and 9. Okay. So now at this point, we can actually go one step further. So as I look at both of these, I can actually factor this one again. How do I know I can factor it again? Well, I kind of look at whatever my criteria was, which was two square terms, minus in the middle, and of course the two terms. So this one can go again one more time. This one I know cannot, because I already saw that guy, right? So this term stays the same, and this one can go into two smaller factors, x and x, 3 times 3, and a plus and a minus, and that is actually the final answer for number 8. So now we kind of say, how would I know if I have to factor again? Well, this x squared was a hint that I might have to factor again. Whenever I have an x squared, I always kind of take another look. So if I look up here, no squares, and over here there were no squares. Here there was a square, but that's a plain old b right there. See, this first half could have been factored again, but that back half is a no-go. So we'll look at more examples of that, but that is how to factor with the difference of squares.